All right, so let's start with our speaker. So Venkatesh will be speaking with infrastructure as a code, quite interesting stuff. So let's go. Venkatesh, you're welcome.
Okay. Hope you're able to see my screen. Sorry, you're able to see me. Let me quickly share my screen. Yeah. Hello, everyone. Good afternoon. Good morning. How are you doing? I hope everyone is safe and staying home. Okay. Okay, fine. This is Venkatesh Ganta. I'm working with EPAM as a cloud and DevOps engineer in EPAM India, and my team, like we have who contributed to the POC. It's Uday Kumar Dantuluri, Omkar Kulkarni, and today we are talking about the topic disaster recovery reference architectures and IAC modules. Okay, so before getting into the topic, I just quickly wanted to share some disaster recovery scenarios so that we'll get a predefined idea of what we are talking about and what the exact problem statement and the solution is about. Okay, so let's discuss about the disaster recovery scenario 1, which happened long back and which happened back in March 2017 with Amazon's massive AWS outage, which was caused by human error. Okay, so it was caused because of AWS engineer who is working on a billing system, debugging some billing system, and accidentally he's turned off the servers which are not part of it, and that made a massive effect on the US East 1 North Virginia region, and that affected on the S3 services, because as part of that incident, the AWS team has to restart multiple subsystems, which are related to the S3 in that region, and in turn, S3 service API calls were not working. With that in effect, the other dependent services on S3, something like EC2, EBS, Lambda services, which started failing. So that's the reason we face some issue. We face some issue in the North Virginia US East 1 region. So this is one of the scenario where a human error could be the disaster recovery for IT system. And disaster recovery scenario 2, which I'm talking about, it is about the Equinox data center outage, which happened in the 2018, and this is because of a East Coast weather disruption to the one of the Equinox data center, which hosts the direct links, AWS Direct Connect links. So as part of that, some of the multiple AWS Direct Connect links went down, and as per the information, it is caused because of the weather disruptions and the power outages in that data centers. And AWS have suppressed it Alexa alarms, and it resolved it, and it tried with other contingent plans what AWS has, but it's still not able to. It could not protect some of the customers which which made use of the direct connect, which are using the direct connect for a private link, because AWS Direct Connect is a private link from your own data center to the AWS. Okay, so that is where there is a FAQ which was written in as is something like this. So AWS does not offer a service level agreement for direct connect. According to the FAQ, it is asking the customers to have a redundant direct connect links to prevent the outages and enable bidirectional forwarding detection. And this ensures the drops in the connectivity and detecting it quickly. So this is where we have to concentrate on like whenever we are moving to cloud, we have to concentrate on the services, analyze the services, and have some backup plans to the services what are in the cloud. Okay, so this is one of the second scenario. Let's not limit the discussion only to AWS cloud. It happens with any cloud, either it is Google Cloud or Azure. So some other scenarios which happened very recently with the Azure, according to the information of Benefit Nines, it's something like on October 6th, it has outage related to Azure front door, and it had a rippling effect on the Azure DevOps. Okay, and post to that there was a there was Azure WAN outage as well, and which affected the traffic routing, and it reduced the optimal routing of the network, and also it led to the effect of it also affected on the Azure DevOps too. Okay, so these are the three scenarios. Why I was introducing these three scenarios, because we wanted to discuss something which is very related to these kind of real-time scenarios when we are hosting our applications on AWS cloud or Azure cloud or any Google cloud, and what kind of measures, what kind of tools we have to instrument, what are the different areas which we have to concentrate on when we are moving to cloud, because in cloud it's not that like we are managing our infrastructure is owned by someone else and they will manage the services, and the past three errors which I was discussing, it is common everywhere in the data centers. Okay, so today what most of us are doing today, okay, so most of us are doing today that like we are selecting some of the managed services most often, most of the time, and looking at the nine nines of 11 nines or 9 nines of managed services high availability. We are thinking that these services are highly available, and we may not need to plan about these services in the production systems, but that's not the case. So this is where we have to realize, and we have to instrument some tools and make some awareness to the teams, read through the clear picture of the particular service which we are using. Okay, so let's discuss about the calculation of nines. Most of us talk about calculation of nines. Most of us talk about the 9 nines, 11 nines, but what is behind that calculation of nines? It is about dividing the percentage of availability by 365 days or 366 days. Okay, so here we have a list of table where I'll touch some of the rows, something like 99.49s, where we need to have 52.56 minutes of downtime per year, and it's not like we need to have a 52.56 minutes. It is the allowed time per year, and allowed time per month 4 minutes, allowed time per week it is around 1 minute. So looking at the last row in the table, it is 99.99, which is almost in the milliseconds. So it is very ideal to reach or to design or to maintain a system such that we have to maintain we have to maintain very less downtime when we are giving a services in the form of highly available systems, right? So this is where we have to think that it's not pertaining to any service of a cloud provider which is managed, and we should not calculate based on that cloud provider managed service. We should think our application as a whole subsystem and calculate the step by step stages what we have in what is there in the process, and as part of the deployment, as part of the maintenance, as part of the support and all. Okay, so let's discuss what is availability. So we are discussing about the 9 nines, right? So availability is a measure of time to in which our application is in the usable state. Almost like every time it is measured in the nines, in the percentage of time. And as part of this, some of the business continuity plans will not consider, like some of them will not consider the scheduled downtimes as part of their availability. So scheduled downtimes do not count towards their availability, but it may impact the customer satisfaction metrics, as everyone know. But at the end of the day, we have to maintain our system 24/7 and 365 days, and make it as highly available and very reachable to the customer. Let's discuss something on the reliability. So these are some of the measures, whether it is availability or reliability. These are some of the measures which shows the stability of our application. So reliability is taken for the period of time, and it is the probability of service serving the customer. So as part of these calculations, we have something measurement, something like MTTF and MTTR, which is mean time to failure. The time taken, time taken to the failure and repair, like time taken to the repair, and it sum up and makes a formula mean time between the failure. Why we are going for this calculation? This calculation is important because when is your system going down, when is your system coming back, and what is the mean difference between the time and how often it is happening, and what is the probability of that happening per day or per a year or per a week, right? So these are some of the calculations which we should be aware of when we are hosting a service or hosting a application, which are very critical for the business. Okay, so most often when we are thinking about the high availability, every AWS engineer or any DevOps engineer or cloud engineer, most often they'll go with the architecture something like a high availability, which has a cross zone instances, auto scaled, load balanced, and have enough compute functions which can serve the customers within the availability zone or within the region. But this is not the case where a particular region goes down. So in the first scenario, which I've explained about the US East 1 region, the outage. So in that scenario, if you're going with this particular type of architectures, we'll be in a situation where we will not have an application in the region, and we should be keep waiting for the region to come back, and we have to restart our services, make sure our application is completely integrated and up and running, and we have to run our sanity checks and all. And post to that, recovering from that scenario, it will become very problematic for an individual or organization to maintain it and recover it back. That is where disaster recovery starts. So where high availability stops, disaster recovery starts. So this is a statement which helps us to understand that it's not sufficient if you are highly available across the zones. It is not sufficient if you are having a highly availability systems. We should be in a position that if at all, if a particular data center or a group of data center compounded to a region, if it goes down, what is the impact to our business, what is the impact to our services, what is the impact to our customers. So that is where we have to think about the disaster recovery models. Okay, so let's discuss something about the disaster recovery, some of the disasters, the disaster recovery. Like when we talk about the disaster recovery involves a set of policies, tools, procedures that includes the automation of your build, automation of your propagating your artifact to the higher environments, propagating like if it is a sudden change, emergency change, which need to fix a bug in the production system. All these automations, automating your infrastructure as a code, automating your deployments, and so proactive alerting. All this includes are part of the disaster recovery as pre-disaster recovery configurations as well, and post-disaster recovery configurations, something like restoring the data from the snapshots, restoring the data from any backup devices. So let's discuss some of the causes of the disaster recovery. So we have seen some scenarios, some examples in the first couple of slides, but other than that, we have some other scenarios like where we can have fire explosions, hacker attacks, or bugs or viruses like ransomware or unexpected updates, or something similar, something related to the compatibility between the applications, or something related to the server failure, or if a power outage, or some human errors, or some unresponse from any switch. So anything related to these kind of scenarios will cause a disasters in the IT systems. So that is where we have to be proactive and have some plan and make disaster recovery plans. So some other examples related to the same disaster recovery scenarios like DNS failure, a faulty switch, as I said in this earlier slide, or network backbone ISP outages, software bugs, a service failures can take down all other dependent systems. Something similar happened in the case of AWS. One of the service is dependent on the other services, something like S3 dependent on EC2 Lambda or S3 EC2 Lambda EBS are dependent on the S3. That is where, like, if one service is disrupted, and it will affect the other services, and the blast radius of it will be more than what we think about. So that is some other scenarios like a provider failure or a region failure. These are some more examples which you can think about. So what we have to do? So I'm telling everything like we are doing all this, and we're doing like we have these different scenarios. We have different effects on the disaster, on the IT systems disasters. So that is where we have to calculate our disaster recovery measures, and we have to come up with some plans. We have to come up with some automations. We have to design our systems so that they are not only highly available within the regions, it should be available across the regions. And that is where we have a couple of calculations which are very similar to the MTT or MTTF. They call as a whole subsystem called as a recovery time objective, the maximum acceptable length of time that your application can be offline. That is when suppose like if you consider today your at this moment your application is down, and after an hour if you are able to manage and bring up your system, that 1 hour is called as a recovery time objective. So it should be constant, it should be constant, it should be predictable, it should have some business continuity plans revolving around. Based on that we have to take the decisions. And the other measure related to the disaster recovery is about the recovery point objective. Recovery point objective is which is very related to the data or the transactions which we lost during that disaster recovery. So that is where we have to bring down or bring back our application to a point of time before the disaster happened. Either it may be a 1 hour backup what we have taken, or 4 hours backup what we have taken, and that includes both application data, file system data, application data, database related data, and other information which is stored in object storage files. Okay, so one simple example to understand what is RTO and RPO. If it takes 2 hours to restore the last backup that was done 4 hours ago, 2 hours to restore the backup is the RTO, and 4 hours back data which you are restoring is called as a RPO. But it is not always absolute when you are estimating it. It may be more than or approximate to the 2 hours or 4 hours. So some other examples, like if a master fails and the slave is in 10 minutes behind, then your RPO will become less than 10 minutes. RPO cannot be less than 10 minutes. And if the application needs to be bounced to update the DB connection, and then it takes more than 10 minutes, right? So these are simple calculations, the initial calculations of our disaster recovery models. So let's discuss about some real-time scenarios where how a business is tolerating the downtime of an application. So if you consider a bank, a RPO greater than a few minutes is almost like very huge loss in the transactions. And if an online broker system is down for a few minutes, then it will lose a lot of trades. And if a media company RTO greater than a few minutes, there will be a lot of angry tweets that reduces the interest from the customers or interest from the users which are using it. But if in case of a static website, a weekly backups are acceptable with the RPO of 1 week. Okay, so this is where we have to think about the business. We have to think about the real-time scenarios. Just I'm simulating the scenarios or assuming that there is a failure, and we have to come up with a disaster recovery plans. So if a business based on the business discussions, based on the application importance, everyone like most of us think that like if we create zero RTO and RPO values, that like with that we can sustain our systems. But that's not the case. There are a lot of factors which will affect the disaster recovery model, and making a RTO RPO values to 0 is almost like it's an ideal situation. Okay, so where we have a lot of measures like before we are doing a RTO RPO calculations, or before we are going for a disaster recovery plans, we have to start measuring the current RTO RPO values, automate the infrastructure build, detect anomalies across the board, practice the disaster recovery plans regularly. Service health monitoring is very critical, where you have to regularly monitor your application health. And sometimes you have to inject failures in the infrastructure and measure the readiness of your disaster recovery. And writing some run books, something like automated Terraforms, automated Ansible or Chef cookbooks, and making very readily available automated scripts is very important to recover back your system. And in the cloud, there are no edge cases. We should remember this, and we should not think that like if we are making use of a managed service, that's not our end. That's not the end of the job. So we should think the system as a whole subsystem, like whole in the point of a customer view, and we should plan our disaster recovery. And the last point, not all components are equal, neither should be their DRs. Yes, this is true, because it's not that like some of the services which are provided by the any cloud, something like Elasticsearch or Elasticsearch service, or some other services which are not highly available across the regions. They are highly available within the region. That is where we have to take an action, and we have to have some backup plans. So what is the problem statement which we are trying to solve forward? Okay, so far we discussed a lot of things related to disaster recovery and all. Right, the problem statement is very simple. We have to we are trying to like when we are trying to implement a disaster recovery plan, there is no reference architectures, there is no widely accepted reference architectures, there is no proven list of library where we have a disaster recovery architectures which are really proved and which have a calculated RTO, RPO values, SLA, SLI, SLO values, network and latency values, cost and geo redundancy values. So these are the different factors which you have to keep in mind when you're designing the disaster recovery solution. So these factors often get confusing, and it takes a lot of time for an individual or a solution architect when he is designing the system. So that is where we thought a simple solution like taking the real-time architectures from the various customers which we are interacting with or working with, and improvising the architectures, defining some calculated RTO, RPO values, because in this case we may not have to spend much time or much cost on the system creation, because they are already created with the customers with the defined IAC modules or any automation using CloudFormation templates kind of. Right, so that is where we can enhance the subsystems, improvise the architectures, and we'll have almost very real-time RTO, RPO, and cost factor values. And opposed to that, it's not the end of the job. Creating some reference architectures, looking at the current architecture, or taking some reference architecture. We also need to make sure that they are very precise, and also create IAC infrastructure modules for it, which has a flexibility to change all the parameters. And it should be very adaptable across the customers. So that is where we will come up with the IAC modules in the repositories, creating the KB pages with required information of architectures and IAC module details. Okay, so let's when we had this solution, what we have to think about, what we as a team thought about, studied the different disaster recovery models, something like a backup and recovery model. So where we have we don't have to maintain a real-time running system in the cross region, but we have to have a regular backups copied to the recovery site, and infrastructure has to be spun up with the on the recovery site using the IAC codes or automation scripts. In this case, we will not incur a lot of money or cost in it to recover it, but RPO, RTO values can be in hours. So that is what we have to keep in mind. And Pilot Light is just extension to the previous one, where we'll have a fully automated infrastructure created, and which is not really fully functional. It is in the stop state to reduce some cost, and we will start them with a defined RTO, RPO values, but still it takes some time to bring up your system when there is a disaster recovery. Warm standby is the another disaster recovery plan, where we'll have a warm standby setup which is running in the cross region, where we'll have a scaled down version which is fully functional, and whenever there is a disaster recovery scenario, we'll just auto scale the instances using the elasticity of the cloud. And multi-site is the disaster recovery architecture model, where we'll have a site-to-site, active configuration, where we'll have our applications up and running and routing our traffic across the regions, either using a weighted policies or it's a failover kind of model, or geolocation, something most of us know, aware of the features like features in the Route 53. In this case, RTO, RPO values will be in few seconds to few minutes, and that depends on the services or the database which we are using, and how we are making use of cross-region replication, and how the cross-region replication is promoted and coming back as a primary instance. And let's talk something about the multi-cloud disaster recovery plan. This is where we have to think about cross-platform, or having a disaster recovery plan across the clouds, or on-prem to cloud, or cloud to cloud. So that is where we have some of the tools provided by AWS Cloud Endure or Azure Site Recovery. Making use of those tools, we can set up a similar kind of multi-site setup, but it will be across the clouds, or from on-premise to cloud. I'll show a scenario where you can see it in the next slide. But at this particular site, at this particular slide, I'm showing one of the reference banking financial architecture, which is in live, which is hosted, and which is part of our one of the engagement. So where we have a subsystem making use of the Elastic Container Services and Aurora MySQL database, which has a primary, secondary, and read replica, cross-region replica created across the region. This is a warm standby architecture which we have studied about, and looking at this architecture, it is very simple. ECS, we have two different ECS clusters spread across different regions. Within the region, they are spread across the availability zones and mapped to the Route 53. And in Route 53, customer asked us to define a failover kind of mechanism for time being. But if you look at these architectures, everyone think that like it's a simple. It makes us feel that what we have in it. I mean, like it's a general regular 3-tier architectures where we have a ECS cluster and the RDS block where it is spread across the read replica, spread across the regions with the read replica. But in fact, other than this, we have something else where we are managing the managed services, something like Elasticsearch. Okay, so Elasticsearch is not it is a managed, though it is a managed service, it is not spread across the region. That is where we have to, in the project, we have to define some automation which will help us to push the delta of the Elastic container cluster, Elasticsearch cluster in one region to the another region, making use of the DynamoDB and DynamoDB streams, and triggering a Lambda function which will read the DynamoDB streams and push the data to the site recovery region, which is US West 2 in case of this customer. So these are some scenarios where we as a team concentrating about and creating the architectures and creating the reference Terraform modules, which will be definitely helpful for any new engagements or any customers which is already struggling with some similar scenarios. And one such similar scenario in the same architecture is about making use of network load balancer and making use of the static IP address of the network load balancer and mapping them to the canonical names of Amazon AMQs. So here, what we are doing is that by default, AWS will not allow us to map the canonical names of Amazon AMQs to the. It will allow us to map. But whenever there is a change in the type of the Amazon AMQ, its canonical name gets changed. That is where tracking those canonical name changes and all, it is a burden for us. And in maintaining especially when we are dealing with the financial architectures, financial applications, I mean about. So that is where we have instrumented the network load balancer and mapped the Amazon AMQs to it, and then mapped it to the Route 53 and maintaining it across the regions. So this is one example of the architectures what we have studied about, and what we have something extra other than the compute function high availability across the regions. So we have a lot of such customers, we have a lot of such architectures where we have to concentrate on think about. Okay, so this is one other scenario where we have to think of about the hybrid disaster recovery model. So hybrid disaster recovery model, it is an automated disaster recovery system using the cloud Endure. Okay, so this is where I was talking about the hybrid cloud disaster recovery plans. So we can make use of services like Cloud Endure, Azure site recovery, and make sure our application is site to site recovered whenever there is a disaster recovery, the disaster in the IT system. So Cloud Endure, to explain this architecture, it is very at a very high level. So what we have to do is like we have to install the Cloud Endure agent on the system on the server. If we consider it is an on-premise server, we have to install the Cloud agent Azure Cloud Endure agent on the server and create like activate in the Cloud Endure console, and it will create a test server for it, and it will have a regular block level code replication process, which will replicate your system from on-premise to either it is cloud to cloud or from on-premise to cloud. It will replicate your system and it will make sure that your latest data is on your targeted cloud. Post to that, it's just matter of triggering I'm sorry. So it's just matter of migrating your test server to a new server with the required compute functions, whatever you are planning about. But in this scenario, we did see some situation, something like where we have to look at the managing the licenses, look at the managing the compatibility versions, managing the infrastructure, operating system versions, availability, and all. Right, but this is one of the system where you can think about the hybrid DR model. If you're not enough confident of a particular cloud server provider, and if you want to, if you think that your application is more mission critical or business critical, then if you want to go for multiple clouds, you can have such similar setups from cloud to cloud, or at least for a data backups. Right. So let's go for a quick demo what we are trying to show, like what we have created so far, what is the progress. So we are going for a 3-tier cross-region disaster recovery architecture, which has a application layer, web layer, and database layer, which is spread across the region with the cross-region replication. So similar architecture, it is very simple. I don't have to explain it. It is auto-scaled across the regions, across the zones, and regular RDS will have a read replica in the cross region, which is not highlighted here. So similar architecture we have created in the Azure, so which makes use of the Azure front door, which makes use of the application service plan and function app and SQL database in the backend, and it will have a geo replication across the region to maintain the synchronous replication of the data across the region. Okay, so post to this, I'll show you. We are maintaining a EPAM repository. I'm sorry, I would have opened it back. Yeah, so we are maintaining the repository where we have the like different architecture related IAC modules, and right now we'll be looking at a simple 3-tier architecture. So which will have application auto scaling group, application load balancer, DNS configuration, RDS, and TF-var files, both US East region and US West region. So similar kind of configurations we have to maintain for other scenarios as well, and we should make sure that our parameters are as flexible as handy to modify and create the infrastructure. Okay, so post to that, like we have triggered this with the Terraform client in one of the hosts, and it created the, for time's sake, I've already opened everything. So it created the application load balancer, application load balancer both at application layer and web layer. So these are some of the configurations which you look at, most of us already aware of. and which is replicated in the other region as well, US West 2, Oregon. And we have enabled some Route 53 configurations with a health check. So this is where it just regularly checks this health, and we created a private hosted zone here. If you look at this private hosted zone, let me edit it. Yeah, if you look at this private hosted zone, currently it is pointing to the primary US East 1 region, and I have enabled a failover routing policy here, which will route to the other region whenever there is a failure with the health check called demo DRT fab. Okay, so looking at the database, we have cross-region replication, and also within the region we have a standby and primary instance. And calculation of RTOs and RPOs, we have some good tools in the market. So making use of those tools, we can simply we have a lot of tools, but this is one of the tool which I came across. So you can just set your recovery objectives, recovery values, how many hours of production time on those servers are you willing to lose, how many setting your like how many hours you can your business go without accessing it with your critical systems, recovery process and data storage, how much of data storage you have, how often you take regular backups. Okay, all these parameters you have to set, and whether it is hosted on cloud or not, all these parameters once you set it just calculates your recovery cost, calculates your times at your RPO values. And I'm not sure how optimum these calculations are, but still we have to do our own calculations as well. But these are at the, like, we can call them as like baby steps or initial steps, where we can define some RTO, RPO values, and based on that we can progress further. So to show, like, this is the application, this is a simple application which I was showing, and these are some of the customers which I have here. So this is a simple application which we have hosted, and this is a like IAC model which we have implemented for the 3-tier architecture. But for the business financial architecture which I was showing, it is showing it is currently in practice, and it is in live with one of the customer, and where we are directly interacting with. But hosting that system will take a lot of cost and effort. That is the reason we are just taking the reference, and we are just verifying the existing architecture models at the customer base, and based on that we are calculating some RTO, RPO values, and creating the Terraform modules and sharing in the repository with a documented practices, something like network load balancer, Elasticsearch, and all. And some more discussions to the same thing, like why we need disaster recovery architectures and IAC modules. That is to maintain a proven library of disaster recovery, as I said, and to calculate the preventive costs using tools like Terraform Cloud, where you don't have to spin up your complete infrastructure. You just have to integrate your repository to the Terraform Cloud and calculate your cost estimations based on the cloud which you are using. As you know, Terraform is a cloud agnostic, and you can use it across, and it reduces the time to market with proven library of design modules, helps in maintaining the proven library of reference architectures that can be used to groom new solution architects. So this is where we have to think about, like, so when we are grooming some new candidates, it in-house practices, this will be very useful. This is one of the use case, but apart from that, like, whenever we are doing a business, or whenever we are going for a new customer engagement, we can have artifacts of proven library recovery architectures. We can have a Terraform Terraform library, where it is a matter of spinning up your library, spinning up your Terraform modules with some modifications in your parameters. Okay, so that is where it's all about. So we have like creating the reference architectures, optimizing it, looking out of the regular compute functions like application web layers. Out of that, like, we'll have a lot of other things, something like auditing your service using Elasticsearch, or making use of AQ services, something like Amazon MQ, right? And what are the next steps we are planning about? So the next step, what we can think about today is like the 2 points, something like providing DR architecture as a service or providing generic Terraform templates for infrastructure as a code to have a fully templatized environment where you can have flexibility to edit the parameters, or create a console or creating the UI, which UI or creating some Confluence page which has a capability to filter the architectures based on the cloud strategies, business domains, RTO, RPO calculations, or uh, disaster recovery models which people are interested about. That's all. Done. Thank you.
All right, thank you, Venkatesh, for the great presentation. This is time for the question set, so feel free to post your questions. We do have already the 6 of them. So the first question is, does Terraform can be used for the disaster recovery setup for multi-region?
Yes. So in this case, I'll address some scenarios, something which we already did for the one of the financial architecture which I was talking about earlier. So using the Terraform, you can using the Terraform capabilities, you have to enable some switches. Something like when you're switching from region 1 to region 2, you have to just it is just a matter of configuring your health checks in the Terraform, configuring your Route 53 configurations in the Terraform, and just passing some live region parameters in the build in the Jenkins and running it, and it will not take much time to switch your system from one region to another region.
All right, thank you. The next question, which routing policy is the best when you considering disaster recovery?
That depends on the business. If you have a lot of cost factor, like if you have a budget, and if you have like if your system is very business critical, and if you are thinking that at the initial stage of application hosting, I don't want to spend much time, then you can go ahead with the failover mechanism. What one of the client is already doing it, where you ideally you don't create it, but during your test phases you'll create it and you'll test it, and once you feel comfortable you can go ahead with other routing policies, something like weighted routing policy or geolocation routing policies. As I said, it depends on the customer. Like if you have a customer base in a different region, and if you want to really host your complex system on your on the other region, then it's better to go with a weighted routing policy and host your application.
All right, so far so good. Great answer. The next question is, which is the best recovery in AWS Glacier or IME images?
What is that question about?
Which is the best in recovery AWS Glacier? This is the Glacier service, or IME images?
AMI images will be the best thing to recover your systems because it's very fast and you can make use of it. But we have to keep in mind that when we are going to a cloud, we should be ready with some regular maintenance jobs, something like cleaning up your snapshots, cleaning up your Amazon machine images. That will reduce the cost, and that will make sure that you have the latest and greatest updates readily available, and with which you can restore your system back.
All right, the question is pretty the same area. What is the best for the disaster recovery, EFS or EBS?
Yeah, EFS has a latency compared to the EBS, and EBS in EBS you have different use cases, like different storage policies, right? So EFS you can make use of it in cases like when you have a shared file system across your applications. But I would suggest better to go with EBS, but make sure that your data is not stored on your application. And if at all, if there is a dependency to store your data on your application, then you have to think about taking the regular snapshots and recreating it back, or at the worst case, you can go for a EFS.
Good, thank you for the answer. And the last question is about any IE-based disaster recovery open source tool for AWS. Can you please suggest any?
Any? Can you please repeat the question?
Yeah, for sure. Any IE-based, I suppose this is the artificial intelligence-based disaster recovery tools that are open sourced. Can you please suggest any of them for the AWS?
Right. So yeah, we do have come across like thought of it during our initial discussions. We have readily available architectures, but it's not proven architectures, because as you know, like most of the AI ML systems are just trying to come up to the production and running their not most of them are real time. That's what I mean about. So we do have reference architectures, that is in our plan, one of the discussion. But to answer your questions, yeah, we have open source disaster recovery models.
All right, no more questions so far. So thanks you, Venkitesh, once again for the great presentation.
Sure. Thank you. Thanks all.
Yes, and we have one more thing, that we do have prizes for the best question set. So let's try to choose one. What was the best question for you, Venkitesh?
Okay.
I can repeat them once again.
Yeah, please repeat it.
Yeah, the first one, what is the best routing policy for when you consider disaster recovery?
Mm-hmm.
What is the best in the AWS disaster recovery Glacier or AMI images?
Mm-hmm.
What is the best for the disaster recovery EFS or EBS? And can you suggest any IE-based disaster recovery open source tool for the AWS?
Yeah, I would go with the EFS and EBS question.
All right.
Okay.
Thank you. All right, thank you once again. So we are mostly completed with our speaker. Thanks again, our speaker, for the great presentation, for the wider audience. It was really nice and interesting one. So thank you.
Thank you. Thanks all.
Thank you. Bye.